broken. It hasn't been broken. No.
Is it just like turned off?
Well, essentially, like the input was the TV over there, which is connected to the VCR. And so when you turned that projector on, it was going right to that source. But the VCR wasn't turned on because it was saying no input source. So if you're no signal, I mean. So if I change the source to like the computer, it's like, there's no. So, you had some problems to do that I put answers to online, and I'm guessing I did them all right because I didn't get any text messages from anybody. I worked those. I did those that afternoon. What was Monday afternoon, and I did them in about 15 minutes. And I was working fast, but I'm gonna make a mistake. But Ross was texting me. I didn't get an email. So did I do them all right, I guess? Oh, there's one. What? So we'll look at that in a second. Someone had reached out and asked me, do I have to know how to make these pictures, like the graphs of these functions, like in my head? And the answer is no. In fact, I use Desmos for probably 2/3 of them. Just so it's just so much quicker. So yeah, you do not have to know how to sketch those graphs in your head. Absolutely use Desmos. So which one do you want me to look at? 99? Is that what you said, Ellie?
I think it was you had to like solve for x because it was like y equals.
Yeah, I'm looking at it right now. Okay, so what did I do wrong?
I didn't write that. I don't think I wrote down.
Oh.
I think your bounds were wrong on the first one.
Okay, so we got. I remember this one. So the two functions were y equals x plus 2 and y equals 2x minus 1. Yes? Okay. And we're spinning this around the x-axis. I mean the y-axis.
It goes below the x-axis because there's no.
But then did they tell me that x equals or y equals 0 was a third part of the boundary?
Oh yeah. Never mind. I think you did it right.
Hold on. So hard to find stuff. We're getting there. So 99, the curves are x plus 2, 2x minus 1, and x equals 0. So that means that this is the bottom, okay? So
Wait, wouldn't that be y
x equals 0 is the y-axis.
Yeah. Y equals 0.
And yes, you are right. I'm an idiot. So you were right, whoever brought this up. Yeah, bitter. Gosh. Sorry. Okay. So that means I got to draw this down further. So I got to go all the way down to where this baby hits. Which this is way out of scale. What? What did you say, Ellie?
Oh, I just asked her. That was what you know.
You want me to graph this on Desmos so you all can see?
Yeah.
See my new projector?
Is it working now?
Yeah.
Yeah.
Where were you 5 minutes? I just.
Yeah, I didn't hear that. Did you mention it?
Are you kidding me?
You were just talking to
We
us.
were talking about it.
We were listening.
Like I stood right here and I just told like 5 minutes about how it was. Like, what in the world? Okay, hold on. So Desmos. So what are my functions? Y equals
Integrals.
y equals what?
Exponential.
X plus
2.
2. Y equals
2x minus 1. X equals 0.
which I shouldn't have to do, but apparently I do. Okay, so here's our region. It's right here. That's it right there. And so now I think you know what I did when I did this. I did the same thing I just did right now. It's amazing how you make the same careless mistake multiple times. I read x equals 0 and I read that as y equals 0. And that's why I use this as the bottom, okay? All right, so this picture is horrible. I mean, it still is the same shape and it would work, but I mean, we might as well make it look prettier. Okay? So now, the big issue here, I think, for us, really shouldn't be what the difference between x equals 0 and y equals 0 is. The big issue for us should be understanding that this had to have been done in 2 pieces. Okay? Because if I draw in a disk here, that disk right there is defined differently than that washer right there. Okay? So we can break this into 2 chunks. All right? So in order to do that, and since we're stacking these things like pancakes, in order to do that, we got to figure out where the switch happens. And it happens along that line right there, which is y equals what? 2? All right, so the first one is going to be pi r. Now the r, what's this line right there? That one's 2x minus 1, right? And this one is x plus 2. So y equals 2x minus 1. When I solve that for x, I get y plus 1 equals 2x, or x equals y plus 1 over 2. So that's my radius for this one. So I'll stack those up from where to where? What's that guy right there? -1. And what's this guy right here we said was 2? So that's going to give the volume of that cone part. Okay, that part that we just found, I mean, that's essentially a cone. Okay? Plus, now we got a washer to contend with. So that's going to be pi outer radius squared. So the outer radius is going to be that right there, that distance right there, which we already found. Y plus 1 over 2 squared minus the inner radius squared, which is this distance right here, which is on the other curve, y equals x plus 2, so x equals y minus 2. squared. And then I'll put dy on the end. Okay, now notice here, I'm jumping to the end. Before we built, when we were doing these before, I was building up each one. Like we would write out the whole washer, then we would set up the integral and put the bounds on. I'm going right to the end now. And then what are the bounds? 2 up to whatever that y value is right there. It's the intersection of those two guys. So algebraically, we could do that. Or we could just look on the Desmos. I think it's 5. Okay? So we happy with that? We comfortable with that? Do you see the importance of drawing a good picture? Like the picture does everything for you. Okay? And I will be honest with you. When I learned this the first time, when I was in high school, so 30 years ago, when I learned this, like, the first time I learned this, I did not have the ability to draw those pictures. For one, I didn't have graphing calculators. In fact, I actually had a graphing calculator that I got as a Christmas gift my junior year of high school, but I didn't know how to use it. It was one of the first graphing calculators that ever came out. Now that's got to tell you something. If I got a graphing calculator for Christmas, that had to sort of seal my destiny as far as what I was going to end up doing with my life. I didn't know that at the time, but I was really excited to get this thing, but I didn't know how to use it. Well, anyway, I couldn't draw these pictures. And the pictures that were always in our textbooks, like, were so eloquently drawn, like they drew the solids, like I didn't understand. I couldn't make sense of them, right? And so when I did this, when I learned this, I tried to just memorize a formula. And I never did these right. I would miss them every single time. Because I just tried to memorize a formula. It's f of x squared, g of x squared, dx, and subtract them. It wasn't until I started teaching this with a graphing calculator. The old TI-84, I went to a workshop like back in 2001 and it was with a TI-83 or TI-84 where someone had written a program. In this workshop, they shared their program with us where it drew the region and then drew those washers. And then all of a sudden it clicked in my head like a light bulb, the light bulb went on. And once I could see that washer, I was like, oh my God, this is so easy. And then from then on out, students thought it was easy. So yeah, the picture is huge. And Desmos is even better, because Desmos gives you the region so fast. The only thing it doesn't do right now is draw in those washers. I'm sure somebody has figured out a way to do it. I just haven't. So, okay, other questions? Do we feel pretty good about this? What I'm going to do is I'm going to create a Delta Math assignment that is this, where you're revolving around on these axes and finding volumes. The only difference with most of the Delta Math problems, they actually want you to compute the answer. So like this problem, they actually want you to compute the answer with a calculator. Okay? So what you would do if this were the Delta Math problem is you would set this all up on your paper and then just stick this into Desmos and then stick this into Desmos and get the numerical answer. That's when on AP calculus, that's what they do. In the AP test, it's typically, if it's a free response question, it would be points for this setup and then point for the answer that you typed in your calculator correctly. Or if it was on the multiple choice, it would just be, what's the volume of this solid? And then it would be 4 answers. So I don't want you to spend time anti-differentiating, this. Could you anti-differentiate this? Yes. What would you have to do? Well, you'd have to expand this. You'd have to expand this. Then you'd have to clean it up and then anti-differentiate each term. I mean, it would be messy, but you could do it. But it's a stupid thing to have you do. That's a lot of work just to get a numerical answer. Silly. Because really, the answer to this problem is that setup. That's the calculus. Okay. So I'm going to create a Delta Math assignment that's going to have you doing some of this, and then you're going to do this over break. And I'm leaning towards, I'm going to make this decision in the next 3 hours, but I'm leaning towards making this like a quiz. Where you can do multiple attempts on it, but it'll count as a quiz. I got to see if I can make Delta Math do that. I want you to be able to have at least more than one attempt, because it's very easy to make it's very easy to make just a typo when you're typing into Desmos. So I want you to be able to have at least more than one attempt to type. Especially since I won't be able to see your setup. If you're doing this paper and pencil, I can see your setup. I'm like, oh, you type it in. So I'm going to post that this afternoon, I guess. Literally, or probably around noon. But let's talk about these shells, these cylinders, a little bit. I think what I'm going to do also with the shells is I'm going to show you this. I'm going to kind of give you exposure to this, and then I'm not going to test you. That's just one way I can keep moving. If we had school tomorrow, I feel better about that. But I can't teach you shells today, and then have spring break. That's messy. But if I show you how it works, I can say I taught it to you. And just because I taught it to you doesn't mean I have to assess it. So don't tell me. So you ready to do that? Well, let's actually do this one. Because this problem right here is actually better done with the other method. Because I don't have to do it as 2 pieces. Okay? So I'm going to redraw this region. Well, that was embarrassing. Okay, let's try that again. So, what would happen if instead of drawing that rectangle that we always draw horizontally, okay, what would happen if we drew that rectangle vertically? Okay? Like that. Now just imagine for a second that rectangle being spun around the axis. Do you see that what it's going to create? If you spin that vertical rectangle around the axis, what it's going to create is a tube like this. You see that? It's going to create like this cylindrical tube. Okay? Wait, I should step that. It's going to create this like cylindrical tube. Okay? Now, how thick is that tube? Like, well, you guys can see it this way, right? How thick is it going to be in this picture? Delta x or dx, right? Eventually, it's going to be infinitely thin. Right? So let's draw what that looks like. I'm a little shaky today. You see it? Or at least half of it? Now, incidentally, do you see, I'm going to draw another one out here. Okay? Do you see that the size of that tube varies based on where it is in the region? Okay? You see that? So let's see if we can come up with what is the volume of one of these tubes. Well, what we're talking about here is really, what's the volume of this? Okay, now when you're thinking about this, and I'm asking you for the volume of this, I'm not talking about how much volume would fill this up. I'm actually talking about what's the volume of this piece of paper, Okay, not the thing that if I poured something into that, like how much could I fill it? How much space is this piece of paper taking up? Okay? Well, if you think about this piece of paper, if you unroll it, that tube, if you unroll it and make it a piece of paper, the volume of this is really just this times the thickness. Right? And we already know what the thickness is. What's the thickness? It's dx, right? So I'm going to put length times width times dx. In fact, I'm going to draw the thing unrolled. And it turns out we know another one of those lengths of that thing unrolled. We know this. Because we know that. We know one of the other sides, like I'm going to label it as this one, because we know that length right there. What is that length right there? Which I highlighted in blue there. It's just the difference in those y values, right? This length right here corresponds to this length right here. Right? And what is that length right there? Right, it's x plus 2 minus 2x minus 1. It's the difference between those curves, right? The only thing now that I got to figure out is that length right there. Well, what is that length right there? Well, isn't that length right there just the circumference of that circle? Okay? The circumference of that circle right there, if I unroll it, that's that other length. Someone trying to get in? No. Okay. So what is the circumference of that circle? Well, if I think about that cylinder right there, Okay, if I think about that cylinder right there, the circumference of that circle is just 2 pi r, right? What's going to determine the radius of that cylinder? This cylinder right here, this red one, versus this orange one. They have different radii, correct? What's determining that?
So the little one is 2x minus 1, and the bigger one is x.
When you say little one and big one, what do you mean?
The one that's like underneath is the little one.
Let's look at this right here. So I'm not sure if I understand. Are you referring to this one as the little one?
No.
This one's the little one?
Yeah.
So what's the radius of this? It's the distance from there to there, right? What's the radius of this one? Okay. They're both on, in that region, right? Isn't what's determining the radius of that tube just where it is in the region? Like its horizontal position in the region? Okay? The radius is actually just x. Like in this orange one, if I go out to there, it's just whatever the x coordinate is, right? So that means that the circumference is just 2 pi x. So what's then the volume of the tube? It's 2 pi x times x plus 2 minus 2x minus 1 dx. So what is that we've just written down there? That's the volume of one of these tubes. You just tell me where horizontally you want to put it. Like I'm going to draw another picture just so you can see that one's kind of marked up. So say I want to put it right here. The radius of that particular tube, if I draw a tube there, the radius of that particular tube is just, hey, what is that x coordinate there? Okay. And the more in this particular case, the further you make x, the bigger you make x, the tubes get smaller, right? And the smaller x is, the tubes get taller. Okay. So now that's the volume of one tube. What's the total volume? Well, we would just add up all of these tubes that were nesting inside of each other, basically. And what are the bounds? For what values of x is this good for? Just the bounds of the region. So what's this one right here? It should be x equals 0, right? And then what's this one right here? I can't remember. It was y equals 5, so x equals 3. Okay. So if you were to stick that into Desmos and get a number, and compute that integral and get a number, and then you were to compare that with the number that you got when you put the other way we did it, with the two separate ones and added those together, you're going to get the same answer. Okay? This technique of finding these volumes is called using cylindrical shells. right? That's what they call it. They're using cylindrical shells. And for 20 years, no, 25 years, I taught cylindrical shells and never knew why they were called cylindrical shells. Like, why are we calling these things, these nested cylinders, you know, well, here's a bunch of nested cylinders. You can see them here. Here's a bunch of nested cylinders, right? These are, I mean, this is basically a bunch of cylinders that are all nested within each other, except these all have the same height. Those nested cylinders would have different heights, right? But why did we call these shells?
If you think of like a turtle shell, not counting for the turtle, you're shell.
Okay, that is a good explanation too, but that's not the one I had this revelation of. I like that. You're talking about the outside, and that actually goes to what we were saying about when we're talking about those volume. We're not talking about the inside volume, which that works with what you're saying too. I had this revelation about 5 years ago when I went to South Carolina at Christmas time to visit my wife's sister and her husband and their family. And on Christmas Day, we all went to the gun range. Like, this is what you do in the South. You go shooting on Christmas Day as a family, right? So, like, I didn't know. I mean, you just go to this place and they give you a handgun or whatever. So we're doing shooting. Like, what happens after you shoot a gun? If you've ever shot a gun or seen it on TV, what happens? What falls out of there? The empty shell casing. And what does it look like? One of these little tubes, because it's really thin. And it's a cylinder. And it cases, I mean, you know, it just cases the bullet and everything else, powder and all that. Oh my gosh, that's why they call it the shell method. Or maybe it's turtle. Yeah.
Wouldn't the lower bound of that be -3 since that's the whole shape?
The lower bound be -3.
Yeah.
Oh, you mean over here?
Yeah.
So you want to go -3 to 3, okay? The answer to your question is no. Well, why not? Because if you do that, you're going to count the shells twice. Because these shells are defined from x equals 0 to x equals 3. If you define shells with that radius from 0 out to 3, you're going to get all of them. Does that make sense?
Yeah.
If you go -3 to 3, your answer will be double. And it's just like when you're doing the discs method, you only stay within the region. Okay? The region that we were rotating initially was just that triangular shape. Right? Other questions? What time did we get there? 21? Okay, I'm going to give you guys one to try on your own. See if you can do it. You ready? And I'm going to just give it to you with, I'm just going to make up a picture so it's easier. I don't have to do anything. Here we go. Ready? This is f of x, and then this is g of x. And I'm going to spin this around x equals 2. Okay? And the shell will look like this. Okay? So I can say that there's sort of a formula that the volume of one of these shells is going to be 2 pi r h times the thickness. What's the thickness going to be? It's dx, right? And then I'm going to give you a little hint, and then I'm going to turn you loose. The radius of this shell is the distance from here to there. Oh, you need bounds, don't you? 0, and we'll say this is 1. See if you can write it. We have 2 minutes. You're actually gonna take 2 minutes. Anybody got it? Think they got it? Oh, I can see. Wait, what are your bounds? Where'd you get that? What are the bounds of the region? The bounds of the region are x equals 0 to x equals 1. Your radius is different. You got it? Oh, yeah. So the most common wrong answer is this. And then integrate that from 0 to 1. That's the most common wrong answer. And what's wrong about it is the radius. The radius is not x, because x is that distance right there. And the radius is that distance right there, which is what? 2 minus x. It could be g of x, but remember it's a g of x. Look, g of x is this distance, not that distance. G of x is a vertical distance. It's this. So you could do that, but then you'd have to find what this is in terms of, when you solve this for x in terms of y, but you got to keep this all in terms of x. So you just leave that as 2 minus x. Hey, have a nice break, everybody.
Can you use this one instead of the one?
You can use this one if you're going around vertical axis, then you don't have to solve for x. What are you gonna do? Over break?
Just this weekend. A gal's trip.
Really? What gals?
Molly Grace, Ellen, Ryan.
Yeah.
Are you going to Florida with the math?
No. Is there a math teacher trip to Florida I wasn't invited to?
Could you evaluate that from the opposite region as well?
What do you mean?
Answer. Like from 0 to 1, can you do it from like 3 to 4?
This, like from here to here?
Yeah.
No, because these heights, like this isn't f and g. Like if you, so like the height was f of x minus g of x.
Yeah.
Like out here at x equals 3, f of 3 minus g of 3 is not necessarily that distance. Like, because f and g, like, you don't know what they're doing on the other side of x equals.
Okay.
You know what I mean?
Yes. All right,
See ya.
why are like all the windows open?
Well, it involves expo cleaner and vomit.
Oh, vomit?
Not real vomit.
Someone left their pen.
That's my pen.
Oh, it is?
Do you want it?
No.
And you can have it if you want it.
I don't want it.
I want
I
it.
don't need it.
I'll take it.
It's a nice pen.
Oh, those
I
are good
have-
pens.
I have these pens.
Do you like them?
Yes, I do.
Would you like to keep them?
I don't need it.
I didn't offer it to you.
Guess what I was
I love
just
these
doing
pens
in
so
my
much.
last class.
Wow.
Oh, it's an honor.
It's stress
Go,
management
go.
and wellness.
Billy, Rachel printed, got an email back so where she's going to fill out the application.
Yeah.
From Jerome.
Sure.
Wow. Do you call him Jerome?
Yeah. Nobody goes by their last name. Like it,
But it's not Jerry.
no, it's Jerome.
And what job do you do there, Caddy, and what else?
And like bag room.
Bagger. Are you wanting to get the Evans scholarship?
Not really. I don't want to probably not go to school.
Does it mean you have to go, like, if you apply for the Evans, you have to go to one of those
It's
two
like
schools?
Miami or OSU. And then
I saw Notre Dame on that list.
I think that's for Indiana.
You have to be in Indiana, even though that's a private school.
And you have to like caddy more than like 4 years or something. Which I don't know.
Well, no, it was only 2, according to the.
The two.
Yeah, I think it's what
It may be that.
Who trains you to be a caddy?
Jerome like trains you, and then there's like a packet that you kind of read, and it gives you like the terms and stuff. But it's like your basic golf terms.
When you caddy for someone there, are you like clubbing them? Like, you know what I mean by
Normally
that?
not. Like I mean,
Like, are you
Sometimes
saying
you
I think you need to shoot a 7-iron here?
usually all you do for that is like shoot the yardage, and then they'll tell you what club they want.
Oh, they give you a sight?
Yeah.
Oh my gosh! I was telling Rachel, I was like, oh, you're probably gonna have to learn how to estimate yardage. I was like, you could probably do multiples of 25 pretty easily. A sight, that makes it so much easier.
Yeah.
How many people have bags that you actually have to carry versus roll?
Everybody. The 3 options are either you ride in a golf cart, you can rent like a push cart, and then the last one is a caddy carry. Like caddies never push.
Are they all the bags, like, do they have 2 straps?
Yeah.
It's a little easier with 2 straps.
Yeah.
You alright?
No. Those big bags with 1 strap, that could get
Yeah, some people have like old ones from like
1960.
yeah, and they're like hard leather. Mr. Cologne golfs.
What? Does it really?
Yeah.
Wait, at DCC?
No. When I went to Northmont, I rode with Mr. Brown, and he like told me about how him and Mr. Cologne golf.
We should invite him to go golfing too.
Just the whole Fairmont
Yeah.
staff.
All the Fairmont teachers.
Yeah.
Well, we know Merrick Hipwood.
Easy.
Who else?
I don't know. Jimmy, are you ready then? Yeah, I hope it gets rained out.
Dude, that's gonna suck so much. I'm gonna be so disappointed.
If they cancel and then reschedule for Friday,
No,
then I'll get
stop.
yeah.
It's not hard.
Honestly, they should just cancel. And
What
then,
they do need to do, they need to add like a mile or like an 800. Because the
Yeah,
distance
because-
kids get kind of screwed over
yeah,
because none of that is distance. Yeah. That is bad compared to the probably.
yeah, give me as slow as they want. Because you're on my team.
I still expect a 60 at least for 400.
60.
Can you do that? Okay, you can do it.
If I go to it, maybe.
If Abdel's going to 56, you can go at 60.
No, it's not going to 50.
Well, that's what he said, and Max said he's going to go at 55.
I'll go 54.
Oh my gosh.
What?
These people. Hey, do you guys notice anything here?
Yeah, you gotta project.
No. The funny thing is it was never not working.
What was wrong with it?
I'm an idiot.
Plug it in.
I turn it on, and then I would get this thing that said no input signal. So I just assumed that it was not working.
You gotta plug in the HDMI or the
No.
VGA, whatever you use.
It was plugged in. It was on the wrong source. It was like looking for the signal from the VCR. The VCR was turned off.
Oh my gosh.
But,
Yeah, that doesn't make sense.
Check the how is it connected to the
because
VCR?
I very rarely use the cable source. We only use it for announcements when we have announcements on TV, which we don't even really do anymore.
Yeah.
Well,
You are?
are you on? No. There's
Are you one of the USB people? Who
Yeah,
you are? Are you? You're all you are too? Who? Oh, Jimmy. Oh. Why? Because you're anti-good one.
Yeah, good.
Well, we got it. We figured it out. So I worked out those problems that were in the book for you all, and there was one I did wrong. Number 99. Okay. Number 99 I did wrong because number 99 was number 9 was that region right there. Okay, it was y equals x plus 2 and 2x minus 1. And then when I did the problem, I read x equals 0 as y equals 0. Was that y equals x plus 2, 2x minus 1? So the region looks like this. Okay, that's the region that we're talking about. And that's not the region that I did on my solution. I read that as y equals 0, so I only looked at that part and spun that part around. Now, it doesn't change any of my answer except one thing. If you notice in my solution, there were two pieces because you have to do that in 2 chunks. Why do you have to do that in 2 chunks? Because down here, the disk is defined one way, and it's actually that way all the way until you get to right there, and then it becomes a washer. Okay? So my lower chunk, which is basically just a cone, was this, pi r squared, which r is basically this distance right here on the curve 2x minus 1. So y equals 2x minus 1. That's the x distance there, the horizontal distance. So that's y plus 1 equals 2x. So x equals y plus 1 over 2. So that's what I had. But I only added that up from 0 up to that guy right there. What I should have done is gone all the way down here to -1 up to 2. Okay. So I add that chunk, and then I add the shell or the washers. Okay. So now when I look at those washers in the upper half of that, what is the outer radius? What's the outer radius? Alex, what is it?
Y plus 1 over 2.
Yeah, y plus 1 over 2. Whoopsie. And then what's the inner radius? Yeah. Yeah, it's just y minus 2. And then we're going to add those up from 2 up to whatever this y value is up there, which I believe is 5. Okay? Yeah.
I have a question about 101.
Oh, hold on. Let's finish this one up. Okay, questions about this? Yeah, Gavin.
Not question, but shouldn't that first one be dy? Shouldn't that-
That is dy, I think. It just... No, that looks like an x. Put a tail on it. Okay? So I was definitely interested there that you understand why you have to do that in 2 pieces. Okay? What was your question? 101.
Okay, so I think it's kind of the same thing because you can understand. Because there's a y equals 0, which is the actual like x-axis, but then you like went on both sides.
So 101, you're telling me one of the
Yeah, one of the equations is y equals.
shut the front door. Oh yeah, so I did more than I needed to there. That explains, that's so funny. That explains why all of the problems, the bounds, the intersection points were nice points. And I remember when I did this one, I was like, there's no algebraic solution for this. Like it's an irrational number. I can't believe why after all of these. Like I remember thinking that's weird. So yeah, my lower bound should have been 0 in natural logarithm. Yeah. They didn't tell me that last period. Let's try to, okay, well, before we go on, any other questions? So we feel good about this. I'm going to create a Delta Math assignment that you're going to do over break that is practicing this volume of revolution is. Okay? haven't decided how I'm gonna grade that. Like, I haven't decided if I'm gonna count that as a quiz. I think I'm going to. But I want to make sure you have multiple attempts on them. And the other piece of this is on Delta Math, okay? On Delta Math, when you do these assignments, so far, the problems that I have seen, they're asking you to compute the actual integrals, but you're going to use Desmos or a calculator to compute these intervals. And then you're going to round your answers. Every one of these is going to have an irrational number because there's a pi, multiplied on all of them. So they're all going to be nasty decimal numbers. Okay? So you'll set it up on your paper, then use Desmos to compute. All right? Yesterday or Tuesday, I started to show you guys the other technique of doing a volume of revolution problem. Okay? I want to finish showing you that today and like teaching that to you. I don't think I'm ever going to test you on this. Right? But I can say that I taught it to you. But I don't think I'm going to test you on it. Just because of how things are falling into place right now with content. Yeah. So I'm going to blame this on the pandemic. So what I want you to do, or what we're going to do right now, is we're going to actually do this same problem again. Okay? Because if we do this same problem again, but we do it using the other technique, you don't have to do it as two separate. Okay? So I'm going to leave that there. And then I'm going to draw that region again. Okay? But now what I want you to do is, or what we're going to do together, is instead of drawing the rectangle that we always draw, wait, that's not the region at all. I just looked at Gavin's face and I was like, why do you just make that funny face? Let's try that again. Whew. Yeah, it went like this. There we go. Right? Yeah, much better, right? Instead of drawing that rectangle that we draw, instead of drawing it horizontally like last time, we're going to draw it vertically. Okay? So what happens if I draw this vertically? I get that. And I'm only drawing half of it, just like before, right? But now do we see that we get this tube shape? Okay. And I think on Tuesday in this class we unpacked this maybe a little bit more than we did in the last class. That tube shape, actually, if you unroll it, is just a slab. Okay? And we're really looking for what's the volume of that tube. Now, when we're talking about the volume of that tube, the thing that we need to understand is that we're actually talking about the volume of the material that makes up the tube, not what you can fill inside the tube. Okay, there's a difference. We're talking about the shell of that thing. Okay, and I told you the story about the gun casing shells, like so how thick is that tube? How thick is that tube? Is it dx thick or is it dy thick? It's dx, right? Because when the rectangle's vertical, that's dx. When the rectangle's horizontal, that's dy. Okay? So this is dx thick. Okay, or delta x, and then we make it go to 0. Now this length right here okay, that length right there actually could correspond to that length right there. What is that length right there? It's a function of x. It's actually the difference between two functions of x. What is it, Samuel? It's x plus 2 minus 2x minus 1. Everybody see that? Now the other length is the tough one. Okay? The other length is the tough one. The other length comes from the circumference of the tube. Right? So what is the circumference of a circle? It's 2 pi r times 1. 2 pi r, right? The circumference of a circle is 2 pi r. What is the radius of this tube? Well, I don't know if you can see it, but the radius is just that distance from there to there. Right? And what is that distance? It's just x. Okay? It's changing, right? That radius is changing. If the tube is way up here, it's got a big radius, but it's not very tall. If the tube is down here for a smaller value of x, it's got a really, really small radius, but it's really tall. Okay? So the circumference of the tube is just 2 pi x. Okay? So then what's the volume of one of those tubes? Okay, which they're really called shells, but it's 2 pi x times x plus 2 minus 2x minus 1 dx. So that's the volume of one tube. So what's the total volume going to be? Well, we add up all those tubes. From where to where? What values of, and so when you're trying to figure this out, you have to ask yourself, what values of x will make a tube? 0 to 3. Okay, it's the x bounds of the region. So here's the thing, people. That single interval if you were to, on Desmos, compute that single integral. Now, could you compute that by hand? Like if I held a gun to your head and said, give me the value of that integral, could you do it? You better be able to. I'm not going to shoot anybody, but a lot of talk about shooting, I guess that's what it is. I don't even own a gun. But you should be able to compute that integral by hand. Okay, that was not horrible. But if you computed this integral, okay, got a number, and you computed these two integrals and got a number, it's going to be the same number. Well, provided you added those two together. Okay? Two different ways of doing the same problem. All right? Questions on those? I'm going to see if you can figure out this on your own now. Ready? I'm going to draw a picture for you. This is your test on the shell method. Oh, wow, I missed that one a little bit. Let's try that. Okay, so I've given you a region, okay? And I've given you two functions, but I didn't tell you their rules. I just called them F and G. Okay? I want you to rotate that region around the line x equals 4. Okay? And I want you to write me an integral that will give me the volume of that region in terms of x. Okay? Now I'm going to sort of streamline this for you a little bit. The volume of a shell is really 2 pi r h times the thickness. What's the thickness of one of them shells? Dx. Okay? And the height, when I'm referring to the height, is that distance right there. Okay? You follow me? Okay, so set it up. And then I'll check your answer. Nice picture, Billy. Daniel.
we're trying to figure out here for beautiful. How do you bring that x such that this is true? Would that be how you do it? If only an n to be x for x to be x to be equal. I think I'm writing it for.
Oh,
Like that would be 4 I have to do.
you could probably say, instead of that vertical line, hold it.
Okay, so I couldn't remember what the symbol was. I know like therefore it's 3 odds.
Your radius is not your radius is not
Mm-hmm.
Nope. You have the most common wrong answer, and that's why I gave you this problem. Because I was baiting you. It's like sticking a worm on a hook. So you got two things going on here. Your radius isn't right. And why do you have the h twice?
Oh.
What? But it's 2 pi r h, okay? I'm assuming r is what you meant for that. And then h, you just need that once. But the radius still isn't. Kareem? Are you still writing? Oh, okay. Oh. Where was the distance that you had?
This one.
Yes. Where was what you had? The distance that you had. What did you have there instead? Where is that in the picture? Right. But where is that in the picture? What's that distance? Well, then you don't know why that's the answer.
Well, I do know why.
Show me on the picture why that's the answer.
So, there.
What? Oh, that's not right. Sorry. I was looking at that and I wasn't seeing that you had that written in. Yeah, that's not
What
right.
do you mean that written there? You just pointed to the whole thing.
I don't want to say it out loud. I was looking at this, saw you have X written.
That?
Yeah. It's not that.
That?
My bad. Okay, everybody look up here. Do you want to see the most common wrong answer? The most common wrong answer is this. That's the most common wrong answer. That's the answer that I was expecting you to put initially. Okay? But the deal is, friends, is this right here, you were assuming was the radius. But the radius of that shell is not x. Because if I think about that point right there, okay? That point right there, that distance is x. And this distance, the vertical distance, is f of x minus g of x, right? But that's not the radius of that orange tube. The radius of that orange tube is that distance right there. And what is that distance there? Yay! Did you see what you had? Yeah. All right, how are we doing? Oh, you're still right.
What?
Nikola? What's the radius? Or what we got? Okay. Tell me why you did that. Okay, so wouldn't the 4 come first then? Like, I mean, if this right here, talking about that distance right there, is that bigger or smaller than 4? 4 is all the way, right? So the 4 would go first, right? And then, how far away from 4 is this right here? If that distance right there is x. If this distance is x, the whole thing is 4, how much is this? 4 minus x. Now what you were wanting to put, I'm gonna finish my thought with everybody, because you're not the only one that would have done this. Yes. 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 Okay. Nicole and Gavin both did this initially. Okay? Their radius. Well, let me tell you what the right answer is. I think I've checked everybody's, but the right answer, so this is no. The right answer is this. Okay? What some folks want to do initially is instead of putting x there, they want to put either g of x or f of x. Because they see it's on the curve. They see, oh, that point's on the curve, so when it's on the curve, I use the equation of the curve. But the problem with that is if I'm sitting at this point right here, okay, what you really want to do is subtract 4 from that distance right there. And if I'm sitting at that point right there, g of x is not that distance right there. G of x is that distance. This distance right here is x. In fact, the coordinates of that point right there are x, comma, g of x. Right? I mean, if you look at that point right there, isn't that the coordinate of that point? X, comma, g of x. So your radiuses aren't going to contain the function equation. Your radiuses are just going to contain x or something, some horizontal distance from some other number. Okay? You guys see that? I got still 9 minutes with you, so I'm going to do something else. So you all did I check everybody? Did everybody do that right? At the end of this? Okay, that's beautiful. Okay, I love it. Makes me happy. We didn't do this last period, so don't tell anybody. Okay, so there's the region. Okay? You see that region there? I'm going to create a solid from that region. But I'm not going to create that solid by rotating it. Watch what I do. Don't try to draw this just yet. Just watch. Oops.
Daggone it. When you make one little mistake and the picture gets all jacked.
You guys see that solid?
Yeah. Switch on and plug in line.
Okay? Does that help,
Yeah.
Billy? So this is a solid. Okay? That has this region is right there. It's like as the base. But if I slice this solid, like with a knife, imagine this as a loaf of bread. The slices of bread are going to be these equal, not equal, right triangles, isosceles right triangles. Okay? Meaning that this distance right here and that distance right there are the same. Okay? You follow what I'm saying there? So imagine like going to Big Sky and getting a loaf of bread, and you slice the bread, and then they hand you a perfect equilateral right. I keep saying equilateral. Isosceles right triangle. Okay. Let's say that this right here is f of x, and this right here is 2 and 6. What would the volume of that loaf be? What would the volume of that loaf be? Now, to do this, you need to think, okay? You need to think about what's the volume of one slice. What is one? Oh, here it comes. What? It's going to slam again. No. You know, in 25 years of being in this room, I've never had that door slamming like that. It's weird. What's the volume of one slice? Okay. All right, so people already know. I'm going to give everybody some time to think. Like, give it up. Yeah. You're really close. What's the volume of one slice? Yeah. That's the area of the slice. Don't you?
Is that right? Is that right?
Well, I don't know. I didn't look at yours.
Well, yeah, you said it wrong. Sarah.
I didn't look at yours. Huh?
That's what I have so far. And then I
That is wrong.
don't know the volume of the triangle.
Ah, there you go. Here. Mia. Oh, hold on. You don't know the volume of a triangle because triangles don't have volumes. The triangular slabs have volumes.
1/2 base times height times some thickness. How thick is the slice?
Consider that triangle has 390 angle on either of the equilateral right triangle. I'm saying, like, would it be an equilateral right triangle?
Yeah, I guess. Jimmy, you bought it? No? That's the volume of one slice. So what's the total volume of the whole loaf? Hey, Nicole. Not Nicole. I meant Mia. I said Nicole, but I meant Mia because I just looked over your shoulder. What's that distance right there? And that distance right there? They're the what? They're the same. Is it X? You sure? Isn't it that distance right there? It's what is it, Nicole? Were you mumbling or was that Carrie? It's f of x, right? So the length of one side of the triangle is f of x. The length of the other side of the triangle is f of x. How thick is it? dx. So the volume of one of them slices is 1/2 f of x squared dx. What's the volume of the whole loaf? Add them suckers up. From 0, oh, not 0, stupid idiot. 2 to 6. So the point here is, friends, is like, one, we don't have to create volume by rotating. We can just stack up area. And 2, integration. I mean, we're using integrals to find volume there. And what are we adding up? Here we're adding up pieces of triangle, like triangular little slabs. Like Subway provolone. No, is it provolone that's triangle? No. American. Yeah. Provolone semicircle. We'll do that too. Hey, have a great break. Check your Delta math.
Cheese has holes.
And that's all I have to say
Cheese
about that.
more